All right, new unit time. We're going to be talking about polynomials. Nomials with lots of them. I don't know. Something. This is probably my favorite unit, I think. I don't know. I may say that again. We'll see. It's a lot of fun. We're going to start out with some review from Algebra 1, almost certainly. We're going to remind you of all of the exponent rules. That's where we're going to start. Let's do it. So, what are we talking about? Stuff like this. If we have like bases multiplied, so like x to the a times x to the b, what do we do with that? Well, we add those exponents. So, for example, little mini example, if we have x to the 5 times x to the 3, that would equal x to the 8, right? Because 5 plus 3 is 8. You got it? Good. Great. Next one. Well, if you have like bases divided, so like bases. This would not work. That's what we mean by like bases. Oh, buses. I forgot. I embedded a silly joke because I accidentally had a thing in there. Bases. Like buses. If you have like buses divided, like bases divided. What we mean by like bases, excuse me, is that this number has to be the same, or variable has to be the same. If this was x and then y, we couldn't do nothing. They just got to sit there. We're actually going to see some stuff with multiple bases later when we get to the real examples here in a few minutes, right? So if we have like bases divided, so x to the a divided by x to the b, we subtract the exponent. It's a little mini example. If we have something like y to the 5 over y to the 3rd, that would equal y squared, because 5 minus 3 is 2. Next one. Negative exponents. So what I like to say is negative exponents make the thing change levels. So that's the way I like to describe it. Makes it change levels. If it was on the top, it moves it down to the bottom. If it was on the bottom, it moves it to the top. Now, you notice also, this is a place where I see error being made on problems like this, is that after it's changed levels, or after this has gone down to the denominator, the exponent is now positive. It's the same number, but it's now positive, right? Same thing here. If we got a negative exponent, it goes to the top, and now the exponent is the same thing, but it's positive, right? Which is usually the goal. We don't like our final products to have negative exponents in them, right? So a couple of little mini examples for this. Be something like if we have 5 to the negative 2, that would equal 1 over, so the 5 goes down, 5 squared, which in that case would equal 1 over 25, right? Or if we have something like 1, let's change it up a little bit. Let's kind of add a layer to our example. Let's say 3 over, let's say z to the negative 5. All right, changes levels, goes up to the top. Actually, let's add to this example. Let's add something into the denominator, right? Let's put a 2 over here. 3 over 2 times z to the negative 5. We're kind of layering up our examples because, and the reason I'm doing that, if you hadn't figured that out already, is that negative exponents they're not that bad, but they can be a little confusing, right? And so this is important because the only thing in this particular little mini example, the only thing that is to a negative exponent is the z. So the 2 stays where he's at. We don't move him at all. So this would equal 3, and we're going to take this z to the negative 5th, and we're going to move it up to the top. And then say the 5 becomes positive after we've moved him up to the top. But the 2 is just going to hang out and chillax down there because he wasn't raised to a negative exponent, right? So you don't touch him, right? If we have a power to a power, so x to the a and then raised to the b, we multiply those. So little mini example. If we have, I don't know whether these are getting uglier or less ugly. I don't know. You decide. By the way, if you're not one of my students, or even if you are, you're totally welcome to hit that subscribe button if this content is useful to you at all. That would be really, really grand. So if we have something like L, we don't use L very much. Length squared to the, let's layer in, we're kind of sneaking in some layers, to the -4. Right? So we're going to deal with the power to the power first, and then we're going to deal with the negative in a minute. I usually, with negatives, and this is, when you have a power to a power, you're always going to take care of that. Well, it's not really true. I like to take care of the negative exponents as the last step in a problem like this, and that's just generally helpful. So just throwing that out there. So we've got a power to power. 2 times -4 is -8. So this is L to the -8. Now, since we're sneaking in extra example, we don't like that negative. We don't like to leave our exponents negative in the end. So this turns into 1 over L to the 8th. Beautiful. One more rule, and then we've got some examples. Oh, just kidding. 3 more rules, and then we've got some examples. Forgot about these two in here. So if we have things that are multiplied, then raised to a power, you kind of, it's not really the distributive property, but you kind of distribute it, right? So that exponent ends up being applied to both things. So as a mini example, this could be something like, definitely uglier than the last one. Could be something like a to the, we're going to sneak in a couple of things. I didn't even mean to do that, but I said to the, and then I got excited. So a cubed b squared to the 5th. So now we've got kind of doubled up. We've got a power to power, and then we've got this power of a product as well, right? So we're going to distribute that, but since we have a power to a power, what are you going to do with these numbers? You're going to go back to that last slide, and you're going to multiply them, right? So this is going to end up being a to the 15th, b to the 10th, because 3 times 5 is 15, 2 times 5 is 10. Blammo. Neither one. It's cousin. The power of a quotient, right? So it's the same idea. This power here kind of gets distributed to these, so it gets applied to the top and the bottom. We've seen stuff kind of like that before, where you have like a square root on the top and the bottom. It gets square root of fraction gets applied to square root of the top, square root of the bottom. We're actually going to learn in a chapter or two that square roots are just fraction exponents. Panic ensues for the future. Don't worry, don't stress later. It's actually pretty cool. You'll learn it later. So let's do a mini example. So example, you might be like, are you just making up these little mini examples? Yes, I am. So how about p to the 5th over s to the -3rd. Look at all the stuff we're sneaking in here. To the 3rd, right? So we're going to apply it to the top and the bottom. It's also a power to a power. So we're multiplying them. So p to the 15th over 3 times -3 is -9. So s to the -9. We don't like negative exponents, so we've got to change levels, bring them from the bottom to the top. We started from the bottom. Now we're here. So it turns into s to the 9th. Blamio. This one is like everybody's favorite. You can have, and I'm not even going to do, I'm not going to do like a special example of this one. Anything to the 0 power. Oh, I wrote this one wrong. Anything to the 0 power is not 0. What did I do? Anything to the 0 power is 1. Anything to the 0 power is 1. So we can have this big old thing with all this junk on the top over all this junk on the bottom, plus all this junk and we raise it to the 0, and that equals 1, which is great. You want to see that on a quiz or a test, because if you got all this mess raised to the 0, then the answer is just 1. Done. End of story. Yay. Anything to the 0 is 1. And that's, you need to, it's easy to make, to just blurt out a mistake. I'm tired. I'm recording this late for me. I know, old. It's fine. But it's easy to make that mistake of accidentally saying and then accidentally writing anything to the 0 is 0, because that's false. Anything to the 0 is 1. So make sure you get the right idea in your head, right? Anything to the 0 is 1. Now we're going to do some examples. All right. So let's do it. Simplify. Simplify I stopped writing the instructions after this first set of 2 examples. We're going to do several examples actually, because the instructions are simplify for all of them. Yeah. So looking at this, where do I start? Well, what I like to start with here is I like to start with the coefficients. So these numbers in the front. The numbers in the front, you just multiply. That's it. If they're multiplied. If they're divided, you divide them, right? So 2 times 3 is 6. And then let's take a look at like bases. So we've got a like base right here with this one. If we have like bases multiplied, you add the exponent. So negative 2 plus 3, so that's a to the first. If it's to the first, we can leave it off, right? B, look for like bases. There ain't no like base, so just bring him down. B squared. C, are there any like bases? No, so we're just going to bring him down. We don't like that negative exponent. We got to deal with that. How do we deal with that? Change levels. Bring him from the top to the bottom. All right, 6ab squared all stays on top because they're not negative. They don't have a negative exponent, right? And then the c squared comes down to the bottom. Easy peasy. All right. Over here, we got like bases divided. All right. So what do we do with those? We subtract the exponents. So 2 minus 7 is negative 5. So this turns into q, that's a g, q to the negative 5. And then 4 minus 3, these are like bases, right? So would be r to the first. We don't like that negative exponent. We got to deal with him, take him from the top, bring him to the bottom. So the r stays where he's at because he doesn't have a negative exponent. Bring him down to the bottom, turn it into q to the negative 5. I turned that off on the last video I made this evening, but I guess I turned it back on. Let's fix it. There we go. All right. Next one. All right, we got all kinds of things. We've actually seen this as before a little bit, although we also have a number in there. We have some things. So it's a little bit more complicated. This 3 would get applied to everything. Again, like we saw with our other mini examples, we've got a power to a power, so that 2 gets multiplied with a 3, so does the 4. So this is going to become negative 2 cubed a to the 12th, because 4 times 3 is 12. That might be a 2. That's a little better, right? Over b to the 6th. Why is it the 6th? Because 2 times 3 is 6, right? We got a power to a power. We multiply those, right? So now we need to simplify, and these are not like bases, so we're not going to do anything with those. Negative 2 cubed is negative 8. That's a little tricky because, when we square a negative, it comes out positive, right? Because it's a negative times a negative, which would be positive, right? But if we have 3 of those, we've seen this before. I made kind of a big deal about it before on, I don't even remember what lesson it was. But if we have an odd exponent, we have an odd number of negatives. If we have an odd exponent and we're raising it to an odd exponent, then it comes out negative. If we have an even exponent, it comes out positive. You might want to write that down. All right. So we've got negative 8 a to the 12th over b to the 6th. Beautiful. Next one. All right. We got big old thing here. This guy, what do? Do the same thing as if there were just a couple of them. Wait, first thing we've got to do is distribute that negative, right? Distribute the negative. So this front one, there's nothing in front of this parentheses. So this first set of parentheses, he don't matter. There's nothing there. So the first part just is 4x squared minus 5x plus 2. And then when we distribute that negative, remember that pretty much just flips those signs, right? So this is going to turn into negative 2x squared minus 15x plus 3. Now we're going to look for like terms. This is like with that. This one is like with this one because they're just a single x. And these ones with no x are alike. Now, there's two things that I want to say. One is when we're doing these and we get our polynomial answer, you want to write your answer in descending order. What does that mean? Well, you put your highest power first, and then the next highest, and the next, and the next, and the next, and so on, however many there are. So our highest power here is squared. So that's the one that's going to go first. The second thing is I still, even sometimes in an Algebra 2 class, get this mistake that people will try to combine this with this. Stuff like that. Well, why cannot those be combined? I don't know what happened there. Something. We don't know. It's fine. It's fine. It's okay. Well, this one they're not like terms. This one is x squared and this one is just an x. So make sure you're keeping those separate whenever those are different, right? So 4x squared plus negative 2x is positive 2x squared. And then negative 5x minus 15x is negative 20x. 2 plus 3 is 5. That's as simple as that gets. We're finished. Now, this one. These are fun. These are great fun because these guys, there's nothing in front of this. We're just going to drop the parentheses. Turn this into 8x squared plus 6x minus 1. There isn't nothing in front of this one, admittedly. But if I distribute a plus in there, it does nothing. So these parentheses don't help either. So we're just going to bring it down. Minus 5x squared. Wait, where did the plus go? Why is it just minus? Plus a negative is the same thing as subtraction, right? So I just cleaned it up, right? That's the same thing. Plus 8x plus 1, right? Where's my like terms? This one is alike with that one. This one is alike with that one. And then this last no x terms are alike. So 8x squared plus negative 5x is positive 3x squared. 6x plus 8x is plus 14x. Negative 1 plus 1 is 0. That term just gets canceled. There it is. Finished. We got a couple, three more. I think just a couple more. All right, we got this guy multiplied onto all that. What are we going to do with him? Well, we're just going to distribute him, right? Now, the cool thing here is all that stuff that we were talking about at the beginning of this lesson is still going to apply. So we got 3x times 2x squared. The coefficients, those numbers in the front, we just multiply. So 3 times 2 is 6. Now we've got x times x squared. That's like bases multiplied. What do we do with those exponents? We add them when we have like bases multiplied. So 1, remember there's a 1 if there's nothing there. 1 plus 2 is 3. So this turns into 6 times x cubed. 3x times 5x would be 15x squared because it's x times x. 16x squared. We've seen that recently, right? When we were factoring and we were doing all of that stuff. 3x times negative 12 is negative 36x. It's in descending order. Great. Easy peasy lemon squeezy. Uno mas. All right. I think I'm going to actually move this one down here real quick. Oh, I know. I can't do that. Thanks. Going to go to that and then move it. Oh my gosh. What is happening? Oh, you have to be. I see. I get it. Because I need to have some floopies. I need to have some floopy doops. So, how are we going to do this mess? How are we going to do it? How are we going to do it, y'all? We got this trinomial multiplied times a binomial. Well, here's what we're going to do. We're going to do a big old fat distributive property. We're not going to FOIL, right? That's a shortcut, but we are going to distribute. We're going to do the bloop-a-doo, bloop-a-doo. You know, that's what always happens whenever I ask students in class, what do we need to do next right here? And they're like, and there's almost always a student in the room that's like doing this with their hands. You do the thing with the thing. That's what we're going to do. What are you talking about? I'll show you. We're going to do this times this times that, this times this times that. I'm going to even change colors here because we're going to go this times this and that times that. We're going to multiply everything times everything. Everything. So a squared times a is a cubed. A squared times negative 2 is negative 2a squared. Moving on to the next one. Negative 3a times a is negative 3a squared. Negative 3a times negative 2 is positive 6, because 3 times 2 is 6, right? Positive, because negative times negative is positive. And don't forget that a, because 3a, right? This last one, 4 times a is 4a. That's easy. Plus 4a. And then 4 times negative 2 is, of course, negative 8. That a looks kind of like a wonky 9. Now he's better. Now, we can do a little bit more, right? Because we've got some like terms. We can find those and simplify those on out. This a cubed, he doesn't have any friends, so he's just going to hang out alone in the corner. Always alone. A squared, a, he's also alone. So sad. Maybe they could get together. Well, no, they can't because math rules. It's against the law. All right, so we're just going to bring down that a cubed. Negative 2a squared minus 3a squared is minus 5a squared. 6a plus 4a is plus 10a. Bring down the minus 8. And that's the end of that problem. That's the end of that lesson. Hope you're doing fantastic. I'm doing fantastic. I'm going to go read or something. If you're not one of my students, thanks for joining us. If you are one of my students, do your homework for Pete's sake. I'll see you in class. Y'all stay awesome or something. Bye-bye.